All right, in this section, we're going to find the dot product between two vectors. So we're going to move down here a little bit. And again, these are not the completed notes that you'll find in Canvas, but this will have to do for right now because I'm not done typing. All right, so a dot product is going to give you a scalar for an answer. Okay, it's going to give you a number. It's not going to return a vector. And you just multiply your x components or horizontal components together, plus multiply your vertical or y components together. Okay. Another thing that we're going to do is utilize, if I know two vectors, I can find the angle between them. So the cosine of theta will be the dot product of the two vectors divided by the product of their magnitudes. And then finally, and this is going to relate back up to here, I know that two vectors are orthogonal, which is the fancy word for perpendicular, okay, if their dot product is 0. So if the dot product is 0, you've got vectors at 90-degree angles. So come back up here to parallel. If your angle between the vectors is either 0 or 180, then they're parallel vectors. And that gets a little bit confusing in vector world because, let me see if I can find what I drew before. Hang on, I don't know what I drew. Nope, can't find it. Okay, so if we've got two vectors, so if I draw this one, and I find out that it's, I'm just going to make crap up, okay? I find out that this vector right here has a magnitude of, actually it's going to be easier to work a different way. Hang on. All right, I'm going to say that vector v is going to be 2i plus 3j, okay? And I'm going to say that vector w is going to be 6i plus 9j. Okay, now you'll notice that the ratio, what I did, or something that you should notice, is that if I multiply this vector by 3, I'll get this vector. Okay, so 2 times 3, 3 times 3. So I get this vector back. In other words, vector v is the same thing as 3 times vector v is the same thing as vector w. So since they are scalar multiples of one another, you're going to find out when you draw it that this one is just going to be a little bit longer, but it's going to lay on top. So remember that parallel lines, by definition, have the same slope. They move in the same direction. And so you're thinking, so they're not parallel because they're on top of each other, they're the same vector, but they're not. They have different magnitudes. So if it helps you to think in terms of airplanes, the red airplane, look, it's red, is at an altitude of 2 miles, and the blue airplane is at an altitude of 5 miles. They are moving in the same direction. So you do not want your airplanes to crash. Okay, so what you have is two airplanes that are moving in the same direction. So we say that they are parallel. Okay, so all of that being said, and then what's going to end up being a second video is we're going to have to do a vector decomposition and find projections of vectors. So we're just going to concentrate on dot products first. And notice that, hang on, I'm looking for examples. Okay, so we've got this. All right, so I have, given that v, I lost my blue pen, and I'm really quite traumatized. Found it. All right, so I've got vector v is I plus j. And vector w is going to be I minus j. All right, so part 1, I want to find their dot product. So the dot product, remember that this is a 1, and this is a 1, and this is a 1, and that's a negative 1, okay? So their dot product is going to be found by taking your horizontal components and multiply them. So 1 times 1, and then add it to the product of your vertical components. So that's 1 times negative 1. So 1 plus negative 1 is 0. So what did we decide a while ago? If your dot product is 0, then these two things are orthogonal, which means they're perpendicular, which means the angle between them is 90 degrees. So let's plot this and look at it. If I plot this and come over 1 and right 1, you should recognize that this is a 45-degree right isosceles triangle. Okay? So I just said a whole bunch of things at the same time. It's a right triangle, it's isosceles, because this is 1 and this is 1, which means this right here is 45. Okay? If I do vector W, that means I'm going to come over 1 and I'm going to come down 1. Okay? So I've got this one right here, which recognize that that is also an isosceles right triangle. So this must be 45. So if this is 45 and this is 45, this must be 90. So you just found out that their dot product, if it equals 0, means that the angle between them is 90 degrees. They are orthogonal. Okay? So let's try another one. We have V is going to be 5i plus 2j. And then W is going to be 2i minus 5j. Okay, so I want to find their dot product. So the dot product of V and W means I'm going to multiply my my horizontals together. So I've got 5 times 2 plus, and I'm going to multiply my vertical components together. So 2 times negative 5 is going to be 10 minus 10 is 0. Your dot product is 0. Your vectors are orthogonal. Okay, so what is the angle between them? The angle between them must be 90 degrees. All right, so we have vector V is negative root 3 on I plus 3 on J. Okay, and W is I plus J. So remember that this is a 1 and this is a 1. So I would like to find my dot product. Okay, my dot product is going to be my horizontal components product. So negative root 3 times 1 plus 3 times 1 gives me negative root 3 plus 3. So that is not 0. That is not orthogonal. So I would like to find out what is the angle between these two things. So now that it's not 0, I got some more work to do. Okay, so first of all, notice if your dot product is 0, then 0 divided by anything but 0 is 0. Okay, so even if I had to go through and use this, if it didn't dawn on me that the dot product was 0, I would get, well, the cosine of theta is 0. And so where does cosine have a value of 0? It has it at pi over 2, or at 90 degrees. So right now I've actually got to utilize this. So I've got the cosine of theta is going to be the value of the dot product. So V and W over the magnitude of V times the magnitude of W. So I should probably find these things magnitudes. Okay, so the magnitude of V is going to be the square root of your x component squared. So negative root 3 squared plus your vertical component squared. So negative root 3 times negative root 3 is 3 plus 9 is 12. Okay, I totally lost what I was doing. All right, and then on W, your magnitude for vector W is going to be 1 squared, and 1 squared is going to be root 2. So what I have for my value is negative root 3 plus 3, so that's my dot product, divided by root 12 times root 2, which is root 24. Okay? Now, what are we doing? I need to know the cosine of this angle generates this ratio. The cosine of this angle generates that ratio, which means if I take the arc cosine of this and the arc cosine of this, I'll get an angle measure. So first of all, make sure that you are in degrees, which we are. And I've got the arc cosine of, and I have, hang on, make this darker. It's much better. All right, so negative root 3 plus 3 over, and then root 12 times root 2 is root 24. Oop, what have I done? Goodness gracious. All right, so the square root of 24. All right, so when I do that, I get 75. So the angle between these two vectors, if I were to plot them, is 75 degrees. So theta is 75 degrees. So again, if you plot that, the way it looks is negative root 3, positive 3. So I get this vector. Okay. And then if I got 1 and 1, I've got this vector. So the angle between them is 75 degrees. All right, let's try another one. I have given that V is 2i. And given that W is I would like to know their dot product, and I would like to know the angle between them. So, first of all, notice that you do not have j components, which is okay. That means you have 0 j's. Okay? So my dot product between V and W is going to be your vertical or your horizontal. 2 times 1 is 2, plus 0 times 0 is 0. So their dot product is 2. Now notice something. If this is 1, which it is, and if this is 2, which it is, then these are scalar multiples of one another. In other words, V is double what W is, or W is half of what V is. These are scalar multiples. So if I graph these on the same coordinate plane, what I have for vector V is he is 2i, okay? And what I have for vector W is he is 1i, which means you've got vectors going in the same direction. So guess what they are called? They are called parallel, okay? They are called parallel. And what you will find out is, let's do the dot product. Okay, so I've got the cosine, I already did the dot product, of the dot product over the magnitude. So what's the magnitude of V? Well, it's going to be the square root of your horizontal squared plus your vertical squared. Okay, so the square root of that is 2. So that's 4. And then what is this one? It's going to be the square root of 1 squared plus 0 squared, which is 1. So this results in an answer of 1. Where does cosine have a ratio of 1? That happens at 0 degrees. That happens at 0 degrees. So let us, that is actually a good place to stop because we need to do decomposition of vectors, and I don't have that typed up for you yet.